Okay, so we'll start from what we left in the last class. So we'll see what is the meaning of LOC. Okay, what is LOC command can do to your data file or to your data frame. Okay, so we'll start from here. So you remember this data set, right? You remember the data set we had in the last class. It's not Titanic, but our school mark sheet in 2023 batch. So you can see these. There were how many rows? Yes. So there are 83 rows and so many columns like their branch, which field they are studying, and what is their name, what is their roll number, what is their email, and different formative component marks and the final marks out of 60. Okay, that is the data file for this, right? Zoom. Okay, so good. So this is the data file, and what we had looked into various commands like head, tail, shape, if you want to know the size, and a mix of tail and head to get the first row, right? And you can also get some subsets, like if you want to extract only the name of the student and the course which they are studying. So you can pass it as a list. So this is known as a list, like unnamed one, that is a that is a column one, and unnamed two, that is column two, okay, of your data set. And you see that you are passing as a square bracket. So this thing is in a square bracket. Whatever you want is in a square bracket, right? So you can see unnamed one and unnamed two. These are the two columns you need to extract. So that you pass as a list. What is a list? You will learn more in your course, in other course, but list means grouping them. Simple idea. List means grouping them. So how you group them? You group them with a square bracket. Fine. So if you want the third column also, I mean, you are not satisfied with this two columns, you want the roll number of the students also. If you want the roll number of the students, what you have to do? You have to pass unnamed 3 in the list, comma, hyphen, unnamed 3 also. Okay. So you will have the roll numbers as well. Agree to this? Okay. So this is how you have a big data set with lot of columns, but you want a subset of those. you want you want say first column I want, third column I want, fifth column I want. So in the square bracket you can write column 1, column 3, column 5. That's it. And pass it. Then it will print only those 3 columns for you. Fine with this? Okay, this is how you create subset of a data set. Subset of a data set is also a data set. Okay, subset of a data set is also a data set, right? Fine. Now let us move to LOC command. What is LOC mean? So LOC is a command through which you can get access to various parts of the data. Okay. LOC is kind of, what's the job of LOC? It's like labeling index in a data set. Okay. You pass index in a data set, index to LOC command, and it will give you the details. Okay. So you can see DF. DF is our data frame we created. DF is our data frame. I hope all of you remember. So you are referring that yes, in that data frame, in DF data frame, you pass LOC function to it. Okay, LOC. So df.loc and bracket 7. So you are worried about the seventh row. You are worried about the seventh row. Okay. So what is present in the seventh row? What your intuition tells. I mean, without looking into the output, you know the data set, right? Each row represents. Each row is a data, but what each row represents? Yes, yes, information of that student, of a particular student. Information of a particular student, right? What is its name? Which branch she is studying? What is the mark? What is the roll number? What is email? All these things, right? So seventh row you are interested in, and therefore you passed 7, and you can see it is the detail of this only student. This only student, all the details are there. You can see what are the details: SODS, MSc, CSDA, roll number is there, the different marks has been shown. Okay. If you want to see the 50th or 53rd row, okay, you can pass 53. So that is LOC. You pass index and it will give you the data of that row. Fine. I hope that is okay. Now you want to see, so keep this in mind, this is very important when we are showing you different outputs. So see, LOC you are giving 0 to 4. You are giving 0 to 4. You know Python starts with 0. Okay. So 0, so what do you need here? What do you need here? So it will give you, it will print all the rows starting from 0th row to the 4th row. So 0th row, first row, second row, third row, fourth row. All things will be printed out. I mean, no. Yeah. Yeah, we can. But I'm like, you already know about this. I mean, you cannot print, even though you don't print, it is okay. But for some people like who are starting out, I'm keeping it very simple. I mean, whatever needs to be printed, I'm showing that you just use print. I mean, this is a bit of disparity between, like, I hope you understand, like some students already know much, some students don't know. It wasn't the messy way. As in, when you the first column shows then down to the second column, then into the next column. But when you without print, it just shows as a data frame itself. It is necessary. So what you want to do? I'm asking. Are easier to understand without? Oh, I mean, you don't want to see the output. Can't see the output. Yeah. So what you? I mean, I'm not understanding what you want. Hmm. Hmm. Okay. Shall we do that? I'll be teaching you. Yeah, I'll look into that next time onwards. So, I mean, if someone is not comfortable without print, you should let me know. If someone is not comfortable with print, also let me know. I mean, last time I told you about print, so I'm taking care of each student because it's a bit messy for some student who can't understand from the start. Anyway, I mean, here we are not trying to understand any kind of a programming aspect. We are just seeing, see, as I told you, what we are trying to do here is just to see the commands which are useful and what kind of output it gives. That's it. It is not that mandatory for you to know the programming part because you're just starting out. That's the part I'm more focusing on. So in that journey, it might not be efficient. In that journey, it might not be efficient. You might not see the data set as a very nice looking data set and all. Okay. Okay, let us be back. Hmm? So this is LOC 0 to 4. Okay. So what you are trying to do here, you will print all the rows from 0 to 4th. Okay. So this is one of the most important aspect. You will see the difference when we look into something else. Okay. So look into that when you pass 0 and 4, all things are printed starting from 0 to 4. This is one of the important part. We'll see the importance after a few slides. Now let us come to something known as ILOC. Okay. So LOC, in LOC, you can even pass the name of the column. We'll see that. Okay. But in ILOC, it only works with index. In ILOC, it only works with index. If you pass row name or column name, it will not work. Only index you have to pass. Okay. That means numbers. That means numbers. So that's one of the difference between LOC and ILOC, but the job is the same. Job is the same. I mean, if you are a bit lazy to type in the name of the column, so you don't need to type the name of the column. You can just give the index of that column. Like I want the third column, fifth column, third to fifth column. So you give 3 column 5. So it will give 3, 4, fifth column. Okay. You don't need to type the name of the columns like in LOC. Okay. So in ILOC, you have to just give the integer index. That's it. And it will do the job for you. But in LOC, it is just the, you can even pass the index, like the integer index and also the name of the column in hyphens. Okay. we'll see that. So another difference I want to mention is, which is more important, is in ILOC, if you see, if I pass 0 to 4, what it printed, and LOC what it did. Yes, so that is one of the most important part or difference you need to note. If you do ILOC 0 to 4, it will not take the fourth one. It will take till 4 minus 1, that is 3. But in LOC, it will take all of them. It will take all of them. So here you are printing 0th row, first row, second row, third row, no fourth. Even though you are passing a 4, even though you are passing a 4 there. Is it okay? I hope that's okay. Hmm? No need to go through this whole data set. You just focus on this. It's visible, right? Last one. Visible. Okay. So now what we are doing is, you can see here that you are printing all the rows. You can see 0 to 83. All the rows are there. Why it printed all the rows? Because of the colon command, like colon. That means you are telling all the rows I want to see. All the rows. But you are interested in only the unnamed 1 and unnamed 2 column. That's it. Okay. So you can see unnamed 1 column is displayed for all the rows. Unnamed 2 column is also displayed for all the rows. Fine. Similarly, you can, so it is not necessary. Some of you might have a wrong interpretation that we can print maybe adjacent columns like that, like unnamed 1, unnamed 2 only we can print. No. You can even print the first column and the last column also. You just have to give the name of it. Okay, it's just for the sake of simplicity I have shown unnamed 1, comma unnamed 2. You can see what it displays, the name of the student and which course it is studying. Okay, that's fine. Now let us see, if you want to see the data of 77th student. Okay, so ILOC 77, it gives you the data of that student. The same thing we did before with LOC command. Okay, so here this the job of ILOC and LOC is the same. Okay, but if you see in LOC, you can pass the name of the columns, but in ILOC you cannot do it. In ILOC it is just index, means only the integer index you can pass it. Okay, so now you see, this is how we do it in ILOC. In ILOC you will never see a name of the column or name of the row displayed, only the index, so df.iloc, you can see 77 to 33, that is a list. If you want so what I want here, if I want to rephrase this command, I want the data of 77 student, second student and 33rd student, and the data should include the first column, the third column and the fifth column. That means the data should include the discipline they are studying, their roll number and their formative marks. Like, so this is how the data question usually comes. Okay, and to answer that question, you type in this command. Okay, so you can see ILOC, you pass it as a list, the 77th, second and 33rd row. Okay, that is as a list, in a square bracket it is, comma, next the column number, column index, the first, the third, the fifth. Fine. Okay. Hmm? Fine. So you can see the same. So you can see it here. 77, second, 33rd is displayed here. Okay. Now let us come to LOC. How it works in LOC. Okay, in LOC you can even give the column names like 135. Instead of 135, you can type in the name of the columns, unnamed 1, comma unnamed 3, comma unnamed 5, and you can see the same output we are getting in both of them. Okay, so your main aspect is to understand the logic here. Okay? So just focus mainly on that. Fine. So maybe this, shall I, this, will this be complicated to some of you? Or shall we proceed with this? Shall we proceed? Okay. Fine. So here I am creating a data frame. So far what we did, is there is a data file, there is a CSV file, comma separated file. What I do, I extracted that. I imported that file and I started to do some analysis on the data set. That is, what is the data of 77 student, what is the roll number of 77 student, which discipline he is studying, right? Those things. Now, this is a method of how to create a data frame. How to create a data frame by yourself. That's the question here. Okay. How to create a data frame. So this is a sample data frame we are creating here. Okay. You can see here, like maybe I would have printed that. Yes. You can see this is the original data frame having this 3 rows. Just it doesn't have any meaning. Like to create a very meaningful data set is actually very difficult. Okay. You will see that when I will teach you data cleaning a bit. Actually, if your whole task is 100% data cleaning and those things comprise of around 85 to 90%. Okay, how to get a good data set to work on. So usually you don't have a good data set actually to work on. You have to perform lot of cleaning, lot of data integration, transformation, those kind of things. Okay, to look it more appropriate, So now, as he suggested, the data is not looking that interesting. Okay, but I want to look it from you guys. Okay. So whenever the project will be, you should show me that how a data frame actually looks like with nicely separated columns with nice grids and those things. Okay. Right. So this is the data frame. So this is how you create it. Okay. This is how you create it. Data curly braces, the name of the column, then what you want in that column, you need to enter that. So you can see just like this, you can create. Of course, you cannot, you have to maintain the size. If you don't maintain the size, you might get some kind of a issue. So this is how it is. It is kind of logically clear, I suppose. It's not that difficult to see or understand. Hmm. So very small data set, pd.data frame data. Okay, you are saying that data is like a data frame and you are saying it in saving it in df. You are saving it in df, short for data frame. Okay. So you are printing it, the original data frame, and this is our original data frame. This is the data frame. Okay. And you are creating a list. Okay. List range 5. So same range command you will learn more in your other course, but range 5 means it will display all the things from 0 to whatever displayed -1. Okay. Range 5 means it will display 0, 1, 2, 3, 4, 5 minus 1. Fine. So that is a list. Okay. List is very important actually. List allows you to create data frames. Okay. List is very important. So whenever list comes in your other course, listen to it very carefully. Okay, you can do a lot of wonders once you know about list. Also about dictionaries. Okay, dictionary in Python. What is a dictionary in Python? These all things you will be learning in other course. So try to be more focused in that parts. Okay. So here what we are doing the same idea. Given a data frame, we are trying to create a subset of the data frame. We are trying to create a subset of the data frame. How we are trying to create a subset of a data frame using ILOC command. You can see ILOC colon. What does colon mean? All the rows, but comma small range. That means all the rows, but I want some part of the columns, not all the columns. Okay. So what is the small range? Small range is 0, 1, 2, 3, 4. Okay. So you can see only those columns are being printed here. 0, 1, 2, 3, 4. Fine. So you can see what is missing here. What is missing in the subset data frame? Hmm? Yes, the last column is missing, right? Because you have given range 5. If you would have given range 6, then you might have considered the last column also. Okay. Is it okay? Okay. 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 Now let us see into something interesting. So alternate, as a pattern, you want to print some columns as a pattern. So so how we do it? The same thing up to here, the same data set. Okay, same data frame. you can see I am creating a list with a range comment 0 to 6 comma 2. That means in step of 2, it will skip to step of 2. Okay, so 0 will be there, then 2 will be there, then 4 will be there. 6 won't come. 6 won't come because range prints till 6 minus 1, 5. Okay, but 5 won't be lying in your step 2. Okay, 5 won't be lying in your step 2. Are you understanding? When you do range 0 comma 6 comma 2, what it will do? When you did range 0 comma 6, sorry, range 6, what it did? What it will do? Till 5 it will show. Now you want to not to print all till 5. What you want to do is skip every two columns. Okay. So what it will do? 0 to 6 comma 2. Okay. Range with step 2. You can see it will be 0, then 2 steps, that is 2, then 2 steps, that is 4, then 2 steps, that is 6. But it won't be there. It won't be there because range prints till 5. Okay. Fine. So that you want to print here. So you can see A is printed, B is not printed, C is printed, D is not then printed, E is printed. I hope that is intuitive. So don't worry, you can always go back and do it with your Titanic dataset. So Titanic dataset is your assignment dataset. So therefore, I had to take a dataset from our mark sheet. Okay. So that you can practice it with Titanic, which is freely available. Okay. And this was your assignment, tightening data set. So this is about ILOC and LOC commands. Okay, so what we learned here in this part, in the first half of this lecture, is two things. What does LOC command do? What does ILOC do? Okay, in LOC, you can pass the column names which you want. Okay, but in ILOC, you have to pass only integer index. Okay, like that. So but the job of LOC and ILOC is pretty the same, 90% same, but there are minute differences. In LOC, if you say 0 to 4, it will print 0th row, first row, second row, third row, fourth row. But in ILOC, if you do 0 to 4, it will print 0, 1, 2, 4 minus 1, that is 3. It will stop there. That is the job of LOC and ILOC, to play with index, get any index you want from a dataset. Okay. Then we also learned how to create your own data frame. We created a tiny data set and we stored it as a data frame. Okay. And we saw how to extract all the rows with specific columns, which we are interested in. How you will access all the rows? Using column. Yes, column means all the rows and dedicated selected columns you want to print, that will print for you. Okay. We also saw what is the role of ILOC. Using ILOC, you can actually print every third column repetition, like step of 2, step of 3. That is a bit difficult by doing it in LOC. That's a bit difficult by doing it in LOC if you want to do column names, because column names are categorical. Yes, but this is integer. I think you can still do. You can still do. Maybe that is an assignment. Maybe that is an assignment. You can check for yourself. You can do or you cannot do. But that's a good question. I mean, some people might be shocked. It's okay. Why you need? I have to teach. I mean, I have to teach the important aspect difference between LOC and ILOC. Sometimes LOC comes handy. Sometimes to be honest, sometimes I am really bothered typing columns. I Yes, but you cannot in ILOC, right? ILOC is like if you are lazy and you don't want to type in the column names, you can just give the index. So shall I not teach? I don't know. I mean, there are a lot of things which you can study or which we can skip if you want. If you want, I won't go that much detail. If the class agrees, we should not go that much detail. I mean, we are learning what is LOC, what is ILOC, how to create a data frame. That might be redundant. But Any other things? So the idea is, okay, so we'll see about data preparation. Okay, what is data preparation? You have to prepare your data. That's the basic part. So it needs ample amount of time for that. Okay, don't ever skip this part thinking that it is not that important. Data preparation, data cleaning, data integration actually comprise around 90% of your data analytics or data analysis job. Okay, and those 10% you can just get it through commands, typing commands in Python or Tableau or any other software which you can use. So data preparation, as you can see, takes up around more than 50% of your time, which you dedicate to analysis. So never rush because or skip any data preparation techniques, because if you skip those kind of data preparation techniques, of course, data errors will be coming in your data. Okay, and also like you won't be seeing like that kind of results which you are expected, which you were expecting. So therefore, you will be forced to start the analysis over again. Okay, so the same thing you'll be doing multiple times. So if your data is not cleaned, you have to, or data is missing some values, something, there are many aspects. Data has some noise in it. Okay, in the year column, maybe it is a decimal, like someone would have written 23.5 year age. So like that, you have to be cautious. Sometimes the capital names usually start with capital letters. Okay, so sometimes it is starting with a small letter, some is starting with capital letter. So those kind of things you have to take care. Okay, fine. So this is data preparation. Like we collect the data. Don't you can go through this later. Okay, all the notes for you only. We have made this full paragraph wise. We should collect the data. So you can see collecting data is the process of assembling all the data you need for your machine learning algorithms. Okay, data cleaning, data collection can be tedious. Okay, because data resides from many data sources like laptops, in data warehouse, in clouds, inside many applications, inside many devices, or maybe you have to do some surveys. Okay, in surveys, when you do a survey, maximum chances are people won't feel it very seriously, and you will get lot of data errors there, errors in your data set. Okay, so therefore you have to, you are motivated to clean your data set. Okay, so cleaning data corrects errors, fills in missing data as a step to ensure best quality for your data. Okay, best quality data. Hmm? After you clean your data, you will need to transform, that is known as data transformation, into consistent readable format. Of course, after you clean your data, you have to transform your data in such a way that the transformed data, okay, the transformed data is readable, is understood. Even if after you clean the data is not understood, there is no meaning. Label the data. Data labeling is one of the most important process. So therefore, you can see the mark sheet I have, CSV file. Okay, the column names are not labeled properly. I am telling you unnamed 1, unnamed 2, unnamed 3. Okay, so instead of that, you should have written roll number, course discipline, name of the student, formative 1, formative 2, formative 3, formative total, summative marks. All the columns should be named like that, so that it is easy to get or get any access to any of the columns of the dataset. Okay, fine. So this is known as data labeling. So it's a process of identifying raw data, that is images, text files, videos, and adding one or more meaningful and informative labels so that your ML algorithms can understand them. Fine. So labeling data is important. Okay. So you can, when you do an actual kind of a project, you can actually understand what does this data labeling mean actually. Hmm. Validate and visualize. Of course, when you have gone through the phase of data pre-processing, these are all known as data pre-processing. That means before you get the data, you pre-process the data. You pre-process. Okay. That means the data is coming. So it's just like a vegetable I gave you last time, the example. You have to clean, you have to soak it in water, like good turmeric water, and then after some time you are eating it, right? But are you eating the vegetable? No, you are cutting it. You are cutting it. You are processing it. That is pre-processing. What is then processing? You put it in your frying pan. That is the processing part. Okay. And after that, your data is ready. Okay, the data is ready, right? Then you what you do? That you eat. Do you eat? No, you don't eat. What you do? You visualize the dish. Is it looking good? First thing you do. Dogs also do that. Monkeys also do it, isn't it? Have you seen that? Does any monkey eats whatever you give? No, it will just smell it. Is it the food he wants? Then only he tastes that, right? So that's what you do data storytelling. Okay. So after your data is cleaned, you ran your ML algorithms, you ran different kinds of algorithms on it. You got the analytics from the data set. Fine. Then from that analytics, what story are you telling? What the data set gave you the ideas or insights? What insights are you getting from the data set? That is the most important part. So how you will get the insights? Data set is just comprised of columns, rows. How you will get that insight? You have to find the mean of the age. So you will know what is the age, mean age, which are performing this dance or this choreography or something, right, in a data set. Okay. How many fraction of people under the age 20 to 30 or 20 to 25 died in Titanic? This is my question to you. This is my question to you. This is possible using group by. The question I asked, how many people in your Titanic data set, it has listed of how many people died and all those things, right? So how many people died in the range? How many? I can make it even more specific. How many male persons in Titanic ship died, and those who which age belongs to 25 to 30? How can you get that? Can we give this as an assignment? This question, so that you can think about this. You got the question? Okay, in your Titanic data set, I want to know how many males died, those who fall under the range, on the range of 25 to 30. So you will see that you can use many different functions or commands in Python or in pandas. Age 25 to 30. So you can use that using many different commands. I mean, I should not tell you that you use group by. No, you can maybe do with other commands. Other commands are also possible. Okay, like last time he mixed tail and head to get the first row. Okay, so similarly, you can use different commands to get it done. I want to see. I want to see how you are doing it. But one of the options is group by. Using group by, you can easily do this. I mean, you can tell that yes, I am looking into the male. So you have to look into the gender column. You have to look into the gender column, and you have to tell I want male. And second thing you will say to the pandas command is, group by command is, the age column you are interested in. That age should be in between 25 to 30. And you have to count the number of persons. If you do that, it will just print all the males who have died. But you don't want the names of all of them. You want the number of males who have died. So what kind of command you have to use? You have to use an arithmetic command such that it counts the number of males. There is something known as a count command. Dot count you can use. Or yeah, that you can use. So this is just using group by, you can do this. Using group by operation. Fine. So you can do it without using group by also. But we'll see. That's an assignment. Okay. So note it down. Note it down. So we'll see that next class. Okay. So you can see, like, after your data is cleaned and all those things, like the pre-processing is kind of done, you turn it to data exploration part. Okay, how you will explore data. How you will explore data. So you can see it's the first step of data analysis, used to visualize your data to uncover insights from the start, or identify areas or patterns in your data to dig into more. Okay. So in your data set, maybe you can see that there is a pattern. There is a pattern, that is people who age more than 50 is likely to develop some blood pressure issues, okay, or cholesterol levels, right? So you identify a pattern through the data set only. If you count in which age range blood pressure is high, okay, you will see that when you plot it, when you plot the histogram or you plot a bar plot, you will see the people who are lying in the range of 50 to 60 will are at a higher risk of generating blood pressure or cholesterol levels, okay. That peak will be higher. So that you cannot see by just looking or hovering over data set. That means you cannot look into a tail command. The head command cannot give you this kind of information, okay. So the data visualization can give you this kind of information, which age range is giving you. So it's like finding a pattern in your data set, okay. So which age range we are seeing high level of cholesterol or high level of blood pressure, okay. So that you can only do by visualization. Various types of visualizations are there. You can create a box plot, you can create a histogram, you can create a pie chart, whatever is there, okay, bubble plot, scatter plot, anything, depending. But which kind of plot when to use is important. I mean, some cases, if you are in categorical case or categorical data you have, their pie chart is very much useful. But if you have some numerical data set or something like that, line plots are useful. Sometimes if you want to see the interval range, this to this interval, which is lying, which part of the things are lying, in which features of your data set is lying in that range, then you kind of use histogram, because histogram can cover the ranges for you. So those kind of things we will see in the last part of the course, that is data visualization. In till data visualization, you will be playing with some rows, columns only, okay. You'll be playing with rows, columns, mean, median, mode, those kind of things. But when data visualization comes, you will start seeing very nice looking beautiful plots, okay. So you can see data exploration and visual analytics tools build understanding. Of course, it will build understanding for your case. But sometimes data visualization is not all in all. Sometimes data visualization is not all in all. I mean, if you plot your data set, the numbers, the distribution of your data, it might give you some wrong insights also. You might interpret wrongly. The whatever is done in your plot is correct, but the interpretation you might make might be wrong. So something like that we will see in your data visualization is known as Ascombe's quartet. Okay. So what Ascombe's quartet? If you want to Google, you can Google. Okay, what is Ascombe's quartet? In that aspect, you can see that people often confuse over the distribution of the data points. Okay, what is the mean? In all the cases, the mean, median, mode will be kind of the same, but then one of them might be skewed and those kind of things. So that we will see that data visualization together with some other tools is important for your data exploration. Okay, data visualization is not the only thing sometimes. Okay, so if you only rely with data visualization, sometimes you might make wrong interpretation. That we will see with one of the well-known examples of Ascombe's quartet. Okay, those who want to Google can still Google this Ascombe's quartet. Okay, fine. So you can see, I think most of them we already covered. Fine, so we can go. So why we need to pre-process the data? Okay, so this brings us down, like you need to pre-process your data because we have a lot of, you already know a lot of examples. Some age column might be missing, okay. In names are missing, duplicate columns might be there. Like suppose people who are not that much literate, have computer literacy, what they can do, they can open the Google form, okay, and fill in their data and submit it. Okay, so the data is recorded. Data is recorded in the data set. Now, after 5 minutes, they might feel that the data is not recorded. Again, they type. Okay, instead of Mumbai, they will type Pune. Okay, instead of Mumbai, they will type Bombay. Okay, so, but the name is the same. Okay, the name is the same. Suppose Mr. Arjun. Mr. Arjun is from Mumbai, suppose. Okay. So his title he writes. Okay. Then after 1 hour or after 2 days, he forgets that, oh, I think I did not fill this. Then you again fill this. But while filling this, you are in your old times, maybe. So you instead of Mumbai, you type Bombay. but the same thing, it will treat it as a new data set or new data file, but the column names are redundant. The column names are redundant, right? The same name will be there, everything will be same, but the city you are living is Mumbai in one, Bombay in another. I hope that is okay with some everyone. Is I think it's intuitive. Okay, so like that you can see redundant rows started appearing in your dataset, which is not at all necessary, and that puts extra pressure on your dataset. Why? Because it takes part. If you want a mean, then that plays a role. You are putting the same data twice in your dataset. You are putting the same data twice in your dataset, and mean gets affected by outliers also. You will know. You will see that what is outliers and all we will cover in this class also. One of the important thing. So therefore, we need to clean our data. Sometimes it will be like sometimes, yeah. Sometimes you will see. Sometimes I can write here. Sometimes you can see that the age column, like the money will be like something like this. Okay. Okay, but you don't want to type it in dollars. You want it in rupees. Okay, and moreover that you don't need to type a dollar symbol there. You just have to enter 52,000. Okay, that's the part. You don't have to enter dollar. But if you enter dollar, when you are taking mean, it won't treat it as a number. The dollar symbol is coming. Okay, so that these kind of cleaning you need to do in your data set. Okay, and that happens in any kind of data cleaning project you do. Always you have to clean your data. Okay. So we'll see there are many comments, like sometimes you need to, so for his example, his data is displayed in 2 rows. Okay, so what you can do, you need to drop one of the rows. You need to drop one of the rows, like that you can get back your data, true data, right? How you drop it? There is something known as a drop NA command. Drop NA. Okay, so using drop NA command you can drop that particular row or a column, whichever you want. Okay, so that's the part. So that is about data cleaning. Now what is data integration and transformation? Okay, so data integration means, as I told you, when integration comes, what does it mean? Comes to your mind? To combine. Okay, to combine. Maybe what I want is the data set of whole DUK. Data set of whole DUK. What I need to do, I have to collect data set from SODS. I have to collect data set from other schools. Okay, like informatics and can you name humanities? Okay, all other schools I have to collect the data set. After the data set is being collected in respective formats, I have to integrate them. I have to integrate them. Okay, that is known as data integration. Then only data set of whole DUK will be made. Then only data set of whole DUK will be made, right? Transformation. Sometimes you have to transform your data. Sometimes you have to transform your data. Can you give me some examples? So what happens is sometimes like how I can give you an example. Say like what is your duration here in the UK? 2 weeks. Why you told 2 weeks? Why not 14 days? No, no, no. Let me correct my English. So, how much time it has been in the UK? 2 weeks or 40, someone told 2 weeks also. Someone is telling 14 days also. But if you ask third semester students, what they will tell? Yeah, but why they are not telling 365 days? So that's how it is. I mean, sometimes you don't need to tell about these numbers. Sometimes you don't need to tell about these numbers. You can just tell it like, yes, 2.5 some lakhs, something like that. Okay. So that's how you transform it. Sometimes when you put a log scale, it transforms the data. You will see that if you have outliers, what is an outlier? It's an outcast. Outlier is just like an outcast in your data set. Okay. No example of outcast is there. Any outcast example I can give in this class? Yeah. Any example? How we can give an outcast example? I mean outlier. Okay, let us take this example. Who is the youngest in the class? Who is youngest? 2005, date of birth. 2004. Huh. Okay. 2004, many are there. Okay. Okay. Oldest. 1999. 8, 7, 6, 5, 4. No, finish. Okay. 99 is the highest. Suppose okay. So he is our person there. Okay. So he is kind of an outlier. Okay. We cannot say it is an outlier. We have to do some test that we will learn in this class. We cannot just say that he is the oldest, so he is an outlier. No, no. If his age is 60, suppose one of your school batchmates age is 60, then it's an outlier. It's an outlier because all of you are in the range of around 20 to 25. Okay. But he is 60. So it's a very big gap. So we see a big gap in the age group. Okay. But we still don't know whether it is an outlier or not. There is a particular way to determine that outlier. Okay. So when we distribute the data of your ages, we make a plot. Okay. When you make a plot, right? Like age, according to age, we plot. So what will you see? Most of them are in the 2025 zone, while many of them will be in their 28 or 29 years zone. Okay, zeros will be in the 60th year. Okay, so you'll see that it is like kind of a skewed. Okay, if you have someone in 60 years of age in this class, the data will be skewed. So when I ask you what is the average age of a student in this class, what will happen? You know what will happen? Yes, yes, exactly. What it will be? Because the 60-year-old person is there, he will take part in your mean calculation, and that is a big load into your calculation, and therefore your mean will move towards that 60 zone. Okay, but if that student says that I am done and maybe I can leave this, okay, I can join some other department or something. So he is not there. So when we calculate the mean, that 60 is not there. Then your mean will be kind of balanced. It will be under the range of maybe 20 to 25. Okay, because 90% of you are in the range of 20 to 25. But the moment when you add the 60-year-old person, it goes around more than 30 or 35. Okay, which creates a big of a gap. So in those cases, if you have outliers, mean is not a good central tendency measure to take. Okay, so therefore you face with these issues. Okay, so how to go past these issues? Sometimes if your data set has big outliers like I gave you an example, you can use log transformations. If you use, so can you understand why we can use log transformations? This is a basic example. You can use any kind of log transformation, but there are standard log transformations you can use to make your data, like to convert it into a transform data. Okay. So let us see why we need to use log. Okay, so log means I am telling the base is 10. Okay, log means the base is 10. If I use ln function, it's a natural logarithm, the base is e. Okay, so but I am telling you about this. Okay, I'm not telling about this. Log to the base 10. So if you have log to the base 10, and suppose you are earning around how much? Maybe 10 to the power 5. Okay, 10 to the power 5 rupees. Okay, fine. So can you tell what is the output of this? If you take a log, it will just bring it down to 5 log 10 10. So it will be just 5 into 1, that is 5. So from 10 to the power 5, you got transformation to 5. So that's how you are scaling your data. Okay, sometimes you need scaling of your data set also. There are many types of normalizations also to perform to make your data transformation. Like min-max normalization is there, z-score normalization is there, that we will learn maybe in the next lecture. Okay. So, but these are the kind of things. Sometimes data reduction is also essential, maybe by removing duplicates. Okay, maybe the same version of data you are having again and again in your data set, and that you don't want in your data set. Okay, that is like removing redundancy in your data sets. So that's how you can reduce your data size. Okay, that is known as data reduction. Sometimes it is essential, sometimes your data warehouse or your data what you call data warehouse is not of a big size which can store that much amount of data. Okay, so you need to slim it out, you need to cut it out many parts of your data which is not that essential. Maybe the age of the student in our age in our internal mark grade sheet, age is not required. Is age of student required? No, it is not required. So we no need to have it. In that way, you can eliminate that and reduce your data set. Okay. Discretization, data discretization. This we will learn a bit more. I don't want to spend more time here. Okay. So we'll see what is data discretization in detail. Then you summarize your data, like I mean, after your data pre-processing is done, the main thing you do is analyze your data set. Okay, what information it gives, what insight it gives through various central tendency measures like mean, median, mode, interquartile range, whether it falls under first quartile, second quartile, third quartile, Q1, Q2, Q3. Okay, so I hope you know about Q1, Q2, Q3. Do you know about Q1, Q2, Q3? So I want to say after first data analytics exam, I want to know the top 25% of the scorers. Top 25% of the scorers. That is like Q1. I want to know the top 50% of the score. People who are in the top 50%. That is Q2. Top 75% Q3. Okay. So like that you have to you can analyze your data sets like that. Okay, so why data pre-processing important? Like all this we discussed with various example. We'll just skip, like we'll just see a bit. If you don't have a quality data, you won't have a quality mining results. Okay, that's the aspect of this. I mean, if you don't have a quality data, you won't get good results, right? So therefore, you have to make data of good quality. Okay, and how you will obtain good quality data? By cleaning it, by transforming it. Fine. So you can see that the majority of the work is that part only. That is around 90% of the work is mostly towards data preparation, cleaning and transformation. And that includes majority of the work in a data mining application. Okay. So you'll spend around 90% of your task in data mining. Okay. So 10% you can just apply various commands and those things or visualization techniques you can plot. But those will be very pretty fast. But the data cleaning technique, identifying which is missing, that is a bit of a trick. Fine. So you can see, you can search him, Ralph Kimball. Okay. Data cleaning is one of the most biggest problems in data warehousing. Data cleaning is the number one problem in data warehousing, DCI survey. Okay. Data cleaning task. Usually you see this data cleaning task. Sometimes you have a column and in those columns, suppose here my name is there and someone else's name is there. Okay. So you can see, but this is missing. Okay, this is missing, but other things are there. Other things are there, like age and all other things are there, but the name is missing here. So you have to fill in those missing values. You have to fill in those missing values. Otherwise, there is no meaning of it. Okay. Identify outliers. We will see in today's class what is an outlier and how you identify outliers in your data set. What to do if your data set has noise? Okay, what to do if your data set has noise in it? So noisy data. Okay, what to do if you have noisy data? If you have inconsistent data, if you have inconsistent data, how to correct it? Okay, how to correct inconsistent data? Can you give me an example of inconsistent data in your data set? Hmm? Hmm. That's a simple example we are considering, but something. Yeah, maybe your date of birth. Okay, fine. So someone would have mentioned it as like this. So it is not an appropriate format. It's not an appropriate format. Okay. So you have to follow the DD, MM, YYY format. Okay. So that's a good example. Okay. So if you don't have, that is known as inconsistent data, you have to transform this back to this. Fine. Fine. Okay. Resolve redundancy that we already discussed, like his name is appearing twice. So that is data redundancy. How you can eliminate that row to delete that row and have only one data of under his name. Okay. Not multiple data under his name. That is data redundancy. Fine. So here there are many examples. So data in real world is actually dirty. Okay, to be honest. So a lot of potentially incorrect data, like instrument is faulty. Okay, it can be a human or computer error also. Like maybe your keyboard one key is not working, so you don't enter it properly. Okay, it is transmission error. That is when you are transmitting from one company to another company, the one of the persons who is data entry person, did not type it properly. Okay, human error. Lacking attribute values, that's fine. So you can see occupation is equal to nothing is there. This is one of the fields, one of the features in your data set, occupation, but nothing is there. So that is null. So you can do that by finding is null command in pandas. Okay, you can find how many in your column, in your first column, how many entries are missing. What is the percentage of data missing in your missing data in your first column? Okay, so that you can do it. We'll see in today's class. Sometimes you can see salary is equal to -10. Okay, so salary equal to 0 is understood, but salary -10 is not understood. Okay, maybe he has lot of debt. So anyway, so you can see the age in code names, like sometimes you need rating as ABC, and you don't need rating as 1 2 3. Okay, you need the categorical rating. Okay, categorical rating. So sometimes, and people forget that, and sometimes they type 1 2 3. One is the best one, second is the second place, like that. So fine, that's fine. Okay, so that these are some examples you can see. So noise and outliers you can see here. So this you can see whether the refund status of a person and whether he is, what is this marital status, okay, and what is his taxable income, and is he cheating in that. Okay, these are the few data set here, and you can see that there are some outliers in the data set. So most of the data set you can see that they are in three figures. They are in three figures, but this guy is very nice. Like he has so much of amount here. Okay, so that creates a bit of a eye-catching scenario. Okay, and that's how it is. So this is an outlier. This is an outlier. So is it a mistake? First of all, is it a mistake? Because many of the people fall in that range, but this guy has many zeros to it. Is there a mistake? Maybe he typed more zeros. Okay. And you can see, did he cheat or not is not mentioned. So this null is there. This null aspect is there. So you have to know which parts in your data set is missing. And you have to also check whether there are any unmeaningful entries in your data set, which doesn't have any meaning to it. Okay. So that's okay. And this is also another part, that is which can check for inconsistencies or duplicates. It might be a duplicate. Why it might be a duplicate? Because you can see all the entries are same, all the entries are the same, but one it is married, in one it is single. It might be that it is true. It might be that it can be true, but having all the features the same raises some red flags, raises some red flags. Okay, so that can be a inconsistent data. Okay, that can be an inconsistent data. So if we ask you to explain the process of data cleaning, how to remove redundancy in your data set by giving an example, you can take a similar sort of data set, create your own small tiny data set, and tell that, yeah, this, you see, this is an example. How I gave you an example. This data set is a nice example which tells you about, like, data can be entered as a mistake. Second, it can have null or no filling entry in some of the columns. And third, it can have inconsistencies or duplicates in your data sets. Okay, so three different example it showed. So if in exam or something in your final, if a question is coming like can you explain the missing values, duplicate data, inconsistent data, missing values, or something like that in a by using a data set of your choice? Then create a small data set, meaningful data set, okay, and give an example, okay, and say that yes, this is a column which needs something like that. You can mention even some of the Python commands which you can, if it is asked, maybe it will be asked, list out the Python commands which you will be using to rectify this aspect. Okay, I mean, how to remove this, how to remove this, maybe how to remove this. Can you give me an idea? Any thoughts? I mean, this how many ones? 10,000 $10,000. So maybe dollars, I think. So 10,000 no, might not be a good value. It's an outlier. It might affect your data analysis parts. So what can you do? If it is an outlier, what can you do? Remove the remove the row. But yeah, I mean, instead of that also, you can, removing row is one of the simplest techniques which you can do. Remove the row, okay? But that is not always helpful. If your data set is very tiny, you need a good amount of data to perform the analysis on. So in those kind of situation, when you have less amount of data, you should not remove the rows. Okay, if you have good amount of data sets with the data in your file, you can remove it. You don't need to worry. But suppose you have less amount of data, as in this case 9 only. Okay, so how can we do? One aspect is, if this was missing, if the no value was there, you can take the mean of all of this, and enter the mean here. It can be replaced by the mean or the median. Either of it you can choose. Okay, but you will see that sometimes it is good, sometimes it is not. So that's the main part of this lecture today. That's the main part of this lecture. Whole. Yes, excluding this one. You will see sometimes if you do that, you might be in trouble also. Okay, when you won't be in trouble and when you will be in trouble, there is a slight, very logical thing we should learn today, that I will show you. Okay, anyway, so data is not always available. Okay, so you can see this all are repeated, like equipment malfunction, so many things are repeated. So data is not entered due to any misunderstanding. Fine. So missing data needs to be inferred. That's the idea. So something you have to do with the missing data. Something like either remove that row or fill in with some logical values. That is, it can be a mean, it can be a median, it can be a mode also. How many recurring? If it is a categorical variable, you will see that mode serves as a good criteria. If it is a categorical variable, mode serves as a good criteria. Like if you see this example, what is the mode here in the marital status? Singles are how many? 1, 2, 3, 4. 4 singles are there. Married how many? 1, 2, 3. 3 married. Divorced how many? 2 divorced. So you can see the mode is single. Maximum occurring categorical variable in the marital status is single. The most occurring part in your categorical variable for marital status is single, right? So what does it mean? So you can, if it is missing, if some of your data is missing, you can replace that missing part with single, because the mode is, it maximum occurring is single. Okay, that's a likely option.